Hello all, in this lesson we're going to be studying oxidation and reduction. And this is our first lesson in Unit 11, Oxidation Reduction. Please copy down the do now questions listed here, and you will just copy down the questions but don't answer them, please. Alright, our mini lesson. So first of all, let's talk oxidation. So oxidation is when a substance loses electrons. That's probably the most important thing to remember about oxidation. But there are effects after that. Like for instance, when a substance loses electrons, we know that the electrons are leaving the substance and they're going somewhere else. So their electrons aren't just leaving and going out into space somewhere and never being seen or heard from again. Instead, like if one substance loses an electron, the law of conservation tells us that it has to go somewhere, and it would go to another element which ostensibly would be accepting that electron. Now typically oxidation does usually happen to a metal. The reason for that is because metals have very low ionization energies, which of course is the amount of energy needed to remove an electron. Here is an equation that shows oxidation. You'll definitely want to have this copied down in your notes. There are ways that this equation shows oxidation. For instance, the first one is that you have this neutral metal atom, and it shows the loss of electrons because you have an electron on the right-hand side of the arrow. And in terms of details, of course, if you have a neutral metal atom and it loses a negative charge, then it'll have a positive charge on the right-hand side of the arrow. So yeah, number one, why does copper have a positive charge? That's because it lost a negative charge. And the electron is on the right side of the arrow, or the product side, in order to show that it has been lost. Alright, so let's say that we were not using copper, but instead we were using magnesium metal. How many electrons would be on the product side? How many electrons would be lost? So we can go back to the periodic table for this. When you look up magnesium on the periodic table, you'll find it in group 2, which means that it has 2 valence electrons. And it also means that it'll lose those 2 valence electrons to become stable. Therefore, the number of electrons that will appear on the product side of the arrow for magnesium would be 2 electrons. So another one as a review, why are metals more likely to be oxidized than nonmetals? That's because metals have low ionization energies. So that's sort of the basic story of metals being oxidized, but there is something I'd like to add, which is that if you have a transition metal that's being oxidized, oftentimes you'll get this really colorful layer on the outside of that oxidized metal, and we call that layer a patina. Patinas do have scientific names, and one of the most famous ones that we can all think about is the patina on the Statue of Liberty. You probably knew the Statue of Liberty is actually made of copper, and copper is red in its neutral state. But as it's exposed to oxygen in the air, the oxygen will take electrons from the copper, turning it from free copper into copper ions, whose color is, of course, green. So the name for that is going to be copper oxide. So the green layer on the Statue of Liberty is copper oxide. Okay, so earlier I had mentioned that when a substance loses electrons, that it can't do that in a vacuum, that it has to lose it to something else. So that's where reduction comes in. Reduction is when a second substance accepts the electrons of the first substance that was oxidized. So reduction is the gaining of electrons. If you're thinking about it, you might think that that's a really weird name, that you would use the word reduction for something that's gaining electrons. But just know that this isn't some weird mistake. This is definitely the name we meant to give it, but I'll have a much better explanation for you about why we would call reduction the gaining of electrons tomorrow. So in the next lesson, you'll understand more about that. Here's what it would look like in an equation. Typically it does start with a non-metal atom like chlorine. And we can see that the electron is on the left-hand side of the arrow this time, indicating that it is being gained. And lastly, the product of a reduction reaction will have a charge which is more negative than the original charge. So for instance, if you start out as a neutral charge with a charge of 0, then your charge after reduction would be less than 0. Okay, so why does Cl have a negative charge on the product side of the arrow? Because it gains a negative charge. It gained an electron. And the electron appears on the reactant side or the left-hand side of the arrow to indicate that it has been gained. So let's think about sulfur now. Sulfur is in group 16 on the periodic table. And that means that it has 6 valence electrons and that it would need to gain 2 more. And that's why we would actually give a charge of 2- to a sulfur ion. So why are nonmetals more likely to be reduced than metals? Well, nonmetals have low ionization energies, but maybe a better explanation would be that they have high electronegativities and that they tend to want to gain electrons. So I want to point out in this little graphic at the end of the page that oxidation reactions cannot happen without reduction reactions, and vice versa. They must happen together. If one substance is going to lose an electron, the other substance must gain it. If another substance is going to gain an electron, that has to be from a substance that has lost an electron. So oxidation reduction reactions always happen in pairs. They never don't happen in pairs. And just try to remember that when one material is oxidized, another is reduced, and we don't even think of them as being separate reactions. We call them oxidation reduction reactions, or in some cases we call them redox reactions for short. So be mindful of that word, redox reactions. Alright, so there is a chemical equation that can show redox as a whole. Firstly, you need to show an oxidation. So remember, we have a metal, and it is going to have an electron on the right-hand side of the arrow to show loss, and it'll have a positive ion as a product as well. So that shows oxidation. We need reduction as well, so if you have chlorine, a nonmetal with a high electronegativity, it's going to gain an electron, which is going to be on the left-hand side of the arrow with the chlorine, and on the right-hand side of the arrow you'll just have the chlorine with a negative charge, indicating that it has gained the electron. So for oxidation, electron on the right; for reduction, electron on the left. But we can now combine those equations. So for instance, this electron on the right is actually the same electron as the one that's on the left. So I'm going to cross them out since they're actually the same electron. And then I'll highlight in red the path of the copper. So here's the copper from the oxidation reaction, and there it will be in the full reaction. Here is the chlorine in the reduction reaction, and there it is in the full reaction. And then lastly, what you guys need to see is that we had a copper ion and a chloride ion. Both were products. The copper ion was the product of oxidation, and the chloride ion was the product of reduction. Since they're oppositely charged, they're going to bond together to make an ionic compound, copper chloride. So overall, you can combine these reactions as long as you sort of leave out the electrons. Then you can see that you have a copper atom and a chlorine atom, and they will produce an ionic compound, copper chloride. Alright, and we have reached the pair up. What I need you guys to do is fill in the blanks of questions 1 through 10. Just get the reactions written down first before class starts, and then we'll fill in the blanks in class. But I'm going to leave you with a mnemonic device. So Leo is Greek for lion, so you probably knew that from horoscopes and stuff. And lions roar a lot. Now maybe it's a little bit weird to say this, but maybe you could think of a lion as saying grr. And so maybe Leo the lion says grr, and here's what all that means. Leo the lion says grr, so loss of electrons indicates oxidation, whereas the gain of electrons indicates reduction. So that's a mnemonic device that'll really help you about with the definitions. So we're going to get these guys copied down. We'll fill them out in class tomorrow, and then also these summary questions should be copied down. And we'll fill those out in class tomorrow as well. Thanks for watching.